Alright, hi everyone and welcome back. We hope you have had a delightful lunch. So before we reconvene for the summit, I would just like to encourage all guests to move ahead into the tables that are empty if you guys cannot see. Because I have had some guests tell me that can't see the screen. So if you find an empty table at the front, please feel free to fill them up. And huddle closer, it's raining, it's getting cold. Alright? Now, so as we reconvene, we're excited to present the next session of our summit. Now, our focus for this next part shifts a little to the pressing issue of rapid urbanization. Now, sustainable urban solutions has been gaining popularity in the last 10 years with an aim to tackle the intricate challenges posed by urban growth. Now, these solutions seek to strike a delicate balance between the need to urbanize areas with minimal environmental footprint. So to open for this segment, we would like to invite Doris Peels, Vice President of Consulting at Smart Tech Analysis, to speak to us. Doris, over to you.
Hello, everyone. So my name is Doris Peels, and today we're going to be talking about sustainability. And we all know sustainability is quite the buzzword, and it's quite the thing that we can find often in press releases. And it's quite the thing we can find often on the marketing pages of websites. And with sustainability, something we all would like to do more of. But we don't really end up doing it. It never ends up being a priority in the boardroom, and it never ends up being a priority in our personal lives as well for most of us. And we know somewhere in the back of our heads it needs to, but it's kind of, I said this before, it's kind of like the equivalent of going to the gym. We all want to go to the gym more, but we don't. But the problem is we are talking about our home, the only home we have, and we are destroying it at ever-increasing faster rates, higher rates of destruction, more people, more resources, and more people want more things. And those things are more complex every time. So we're going to be making ever more beautiful landfill. And that landfill is going to be ever more complex and ever more imported from more and more people. Your t-shirt and your laptop are probably the most well-traveled thing about you. And the components of those things come from all over the world. And this is not sustainable. And we kind of forget what that means. That means that we are going to run out of a planet before we run out of history. And then after we run out of a planet, of course, there won't be any history. Of course, well, Elon will be on Mars with 3 of his friends. And he'll decide to cut off your oxygen if you disagree with him. But that's not exactly the big plan I have or hope I have for humanity. So what are we going to do? What are we going to do as a company? What is our responsibility as entrepreneurs or as business people? What is our responsibility as companies? What can we do? And moreover, maybe this is an incredibly good business. And maybe we should appeal to people's greed. Rather than being the people saying, you can't do this, and you can't do that, and you can't eat that, maybe we should say, this is a better thing. If people can sell you 20 flavors of Pringles, maybe we can sell them better, more sustainable solutions. And we're going to talk about this with a couple of gentlemen, and we're talking about, what was said before, how to integrate this urban mobility, this young, fantastic society where everybody wants sushi and everybody wants a walkable city, but they want cool places to go, with a very, very sustainable life. And it's a sustainable life from an urban planning and architectural viewpoint. And we're going to be looking at these with Arthur Wang from MiniWiz, who's looking at recycling things. We're looking at a world where there is no waste because we use everything, not in a stupid way, but in a maybe very advantageous way. Sean Wu is at Witteveen and Bos, and they're an engineering firm, consulting and services firm, and they're looking at new ways of building and new ways of urban planning, maybe doing small interventions that have big effects on people's daily lives, about how you, for example, getting people to commute more, walk more, and things like this. Simon Klintberg is at Cobalt, and Cobalt is a leader in the 3D printing construction space, and they want to disrupt construction. And Pan Yi Cheng is at Typo Architects, and he's an architect who's really, really passionate about solutions. Well, an architect, but also he's worked on buildings and offices and stores and products. And he's really passionate about a new way of doing things and looking at the world through several modalities and trying to figure out what is the best way to redesign our world. So I think this is going to be a really exciting discussion. I think it's going to be a really worthwhile discussion. And I would like to appeal to your hearts, but also perhaps your greed in looking at a new way and how to do this. So thank you very much for your attention. And now I'd like to welcome the first speaker, which is Arthur Wang of MiniWiz. Thank you.
Thank you, Doris. So since he has introduced, then we'll definitely start without further ado. So while we are on the topic of sustainable urban solutions, one of the up and coming trends in the construction industry is to progressively move away from the take, make and dispose model towards a more resource efficient one. So to share with us a little more on how we might be able to achieve zero waste and beyond in the architecture and construction field, please join me in welcoming founder and CEO of Miniwiz, Arthur.
Hello, everyone. I don't know, are we supposed to use this or this? Oh, okay. But in general, I got a bag here. This is Marina Bay Sands bag. This is already made from Singapore waste. Unfortunately, in Singapore, people don't like to spend money on infrastructure. Singapore hate manufacturing, actually. Sorry, I don't mean that in a bad way, but you want to do smart manufacturing, yeah? So dumb manufacturing, we did this. We shipped the trash from from Singapore, collected in Marina Bay Sands, and to Taiwan. And then we recycle it, and we turn it into a yarn and made it into a bag. I know it sounds, just listen to that process. It's horrible. Okay, so it's just a lot of carbon footprint, right? You're shipping trash and a low value, and then you try to get a high value and bring it back here, and now this is 25 Singapore dollars. Okay, so, and this has a bag of trick inside, and then later I think it's served as a discussion. But in general, we've been around for, I don't know how to click.
Oh. We want to matter to the non-toxic future of our world. We want to matter
I guess this helped to do the intro. Yeah.
At Miniwiz, it is our mission to change consumer behavior into a circular one. It is the only way for us as a species to sustainably consume our limited resources. Overconsumption is a complex system problem. There is no single miracle cure. We want to matter by proving human consumption can be satiated with our very own trash. We have dedicated ourselves to turning decades of environmental pollution into solutions that will enable us to live sustainably. We want to matter, so we turn ourselves into magicians of trash, inventing new ways of transforming our everyday trash into high-performance works of art. We turn milk packaging into the hottest sportswear fashion, plastic bottles into luxurious textile, cigarette butts into furnitures and glasses,
using fashion and apparel waste into luxurious home furnishings, masks, PPE into cell phone chargers, single-use medical waste material into hospitals, using smart AI technology to make decentralized recycling, upcycling possible today.
We head to Taiwan for this report, a company designing solutions to overcome a mounting problem of a mountain of trash. From furniture to hospital wards, all built from waste, one CEO is on a mission to revolutionize recycling.
His team has used waste to develop over 1,200 different materials for use in construction, a company turning different kinds of waste, like plastic bottles, into materials for buildings and products across the world.
We want to matter, but unfortunately we are out of time. Please join us in upcycling today's local pollution into circular ESG building solutions of the future.
Okay, so first of all, are you guys all confused with how you recycle these guys? Do we put them in the recycle bin or not? The coffee cups. I mean, obviously it's a trick question, and you guys are a bunch of engineers, looks like, yeah? So it's a trick question. Do we put them in the recycle bin or not? Yes, I see nodding in heads. But welcome, these days are internet societies, you can check. Can you recycle coffee cups or not? Paper ones. No, you cannot. You cannot, okay? You cannot. First of all, it's contaminated with organic waste. Second is has a plastic film, right? That's actually in there. And you need to have a dedicated recycling line. On top is polypropylene, which is a cap. Normally you have to put it separately. And does Singapore recycle those? Nah, definitely not. Okay, so anytime you see recycle coffee cup, please, that's greenwashing. And that's what we are fighting against, actually. There's a lot of greenwashing, but greenwashing is good because without greenwashing, you cannot even get to what we are trying to do now, okay? So, and people talk about microplastic. You know, if you don't recycle your coffee cup properly, all those little bits and pieces of PE actually get broken down and go into become microplastic, okay? And in all the beaches, this is the stuff that you can see. Molecule level is actually quite in a big chunk. You can still collect them. But if you actually get down to the microplastic, every time you wash your clothes, you're actually losing lots of fiber. So every time you have mixed yarn, you are actually dumping microplastic into the sea, actually. You just wash, right? Okay, so I want to show you this beautiful piece of trash. When I was studying architecture and engineering, I'm a civil guy and architects. But this is Augustus Forum, which is when the empire of Roman Empire first built. This is the first fancy offices the Augustus built. Between the two layers of brick is actually a major layer of trash. You can see from there, you can see amphora shards, you can see pipes, you can see leftover building tiles from previous generation of buildings, all stuffed into. This is Pantheon, by the way. This is the most photographed architecture building there is, yeah? And it's the first page of any architecture history books, engineering books, whatever. It's still the largest single-span dome, unenforced dome at the moment. And you see all that white in that drawing. That white is cavity that's filled with trash. Actually, that's just the technique. For this technique to work, they had to invent something. They had to invent cement. Yeah? The cement is what gives the compressive strength. And imagine when we go to these beautiful, timeless buildings, every architect's emulating from, in every one of their presentation, they are actually copying a piece of trash. Yeah? And I just find that a eureka moment when I was 19, 20 years old, when I was in Rome. Okay. So imagine that. Why aren't we doing that today? We're just not very efficient and not very informed. So let me help you to inform that. For those who are interested, everything is recyclable. That's why everyone can put a recycle sign in everything they touch. Technically, right? Everything is recyclable, except just no one's doing it, it costs too much, yeah? So food, packaging, clothing, housing, transportation. This is the current recycling rate of the recycled content within those new products. Okay, the most actually is food packaging already. It can get close to 25%. Recently, you must see a lot of recycled PET bottles or some sort of recycling or 30% recycling into these materials. But in reality, the collection rate is dismal. The collection rate is between 34 in the US and 61 to 62 in Japan, Taiwan, and Germany. And rest of the world, probably Holland's probably quite high up there too. Okay, but rest of the world, 30% or less. Okay, Singapore, I think it's on the lower side, yeah? Okay, but on that collection side, once you collect it, everybody talk about Smurf. We collect, we can use the material. You think you can use the material, you can't. In reality, it actually goes into sorting collectors. Whatever they can use, not contaminated, they will keep and bale and try to sell as a commodity. But rest of that actually goes into heat recycling. So most of the trash here in Singapore is heat recycle, okay? Because you're producing energy, and we call that downcycling. And rest of that goes to landfill. But unfortunately, even if you want to take the collected material, you want to use it for your 3D printers, how are you going to use it? You are missing a lot of information in order for you to actually make that a 3D printing spool. You have to actually get all the recycling specification. You have to have a clean recycling stream. On top, you have to have all the compounding and yarning specs, extrusion specification, which most people just know yours specification you need. So you couldn't influence the recyclers, and they normally need machineries to do that. The C part, which is all kinds of manufacturing technology that's needed, because most manufacturing technology is not designed or engineered for recycled material, because it has a lot of impurities, it has different pressure, and it always have different thicknesses, just to get to a certain structural strength that's needed for the final product. The last part is, if you want to turn that into a building, I will explain why it has to turn into a building. Building specification, huge amount of building specification. VOC, just how much dirty gas is emitting in the air. Just also the structural strength. Fire, what about fire, right? All that specs is missing. And that's why we are dedicated 20 years doing this, trying to get all that specification into one place so we can do what we do today. And why architecture? I think this is very self-explanatory. All the carbon footprint is in building, 50%. Oh, it doesn't matter how you calculate it, 39%, 40%, doesn't matter which data you use. Basically, it's the highest single industry that uses the most carbon footprint. Okay, so period. Unfortunately, why very few companies does this? I don't know, actually. But I think there's one very simple fact, is no money in it. The second thing is really difficult to get in. Have you guys tried to build your building before? Anyone here? It's not easy. You can build it with, if you try to build your building, it is a lot of suppliers and lots of problems with legal stuff. So it's a very chaotic market, and also have lots of status quo in between. And we're going to build more buildings until 2060. And where is that most of that building going? It's not in China. Do you see that bubble, the biggest one? Africa. That's where most of the building activity is going to happen. So if you're going to decarbonize, you want to reduce carbon. By the way, reduce, reuse, recycle. The easiest way for you to reduce carbon is reduce. Just don't use carbon, right? Use as little as possible, right? So this is where what we do. So I kind of basically summarize for you. We only do A and B and C, which is data and software. So to be able to, for you to calculate when you use this material, what is the type of carbon footprint happening, and how is that linking to all the different engineering data. The second is obviously B, which is building product that has a different set of specification that already can be pre-chewed and pre-manufactured into different locations. Decentralizing is the key. If you actually ship trash around, like what I was talking about the bag, horrible. That is antithesis of what we are trying to do. C is then you have to scale those machines locally in a very efficient way. And we have to link that into a real estate development life cycle. A lot of people forget that what they're selling into, you're selling into the biggest user of material are real estate companies, actually. And real estate company, one guy they are most scared of is the government. Because the land is from the government, it has public goods, it's public facing, it's permanent, it's linked to tax policies. You got to think about it. That is the one single, so that's why real estate developer, if you want to talk to the real estate developer, you have better be talking to the government. And you don't want to scale what other people can do better than you. You only scale the part where we accumulate enough knowledge to add value. So we only scale what that part, I think I summarized there. But we can work with lots of creative community. We work with, for example, the Dutch architect, famous Dutch architect, like famous Norwegian architects, Stonehedda. We work with Zaha Hadid, and we help them to deliver a certain low carbon modules within their buildings. And we built a lot of old buildings, not old buildings, like infrastructure building before, and that's where we got our thing. This is the biggest e-waste recycling plant. It has 6 plants inside, one of a big university campus. I just want to point to you the machine. There's a solar power machine there. It's actually Jackie Chan's university. So he says nobody's using DVDs anymore. So can we recycle DVD? So we recycle DVD on site using the solar energy and process that whole process into the facade of this university campuses. So the facade is actually made directly on site. So that's kind of And of course, you want to use the most abundant resources that's available to you locally. So this is in Thailand airport. So this is actually quite big, giant air mattresses, 2,000 square meter with 8 columns. And how is this supported? Air. We're using air as a mechanical tube, yeah? And then we have recycled polyester, 2,000 denier, structural strength, to be able to power that. And just imagine amount of software innovations to do simulations, to calculate whether that works or not, whether the fire, also mechanical strength. So that's kind of what that project represents, trying to use the most abundant material, which is the trash, air, water, sand, that's available on site, yeah? Of course, then rest of that, it gets a little bit more interior, because from exterior to interior, hotels, to Nike stores, Nike lab stores around the world. I know there's not one in Singapore, but if you go to New York, Mercer 21, you go to London, you go to Milan, fancy places around Italy, the cigarette butt store. No, sorry, not cigarette butt store. It's actually the electronic cigarettes, IQOS. It's illegal, I think, in Singapore, but it's everywhere in Europe and Middle East right now. And fashion waste, yeah, fashion waste is one of the biggest, by the way. I'm very proud of Singaporeans. We are the, all the luxurious waste from LVMH. Is it a secret? I don't know. They burn their not sold product here in Singapore. You know why? Because this is an industry secret, but everybody kind of knows. Why? It's because Singaporeans are law-abiding citizens. We don't secretly take these things and sold outside. That's why they set up a burning plant here. Just so you know, all your product every year, how they maintain price is to burn everything. Okay, so we try to capture that and try to dissect it so the LVMH or any of these brand logo no longer there, right? The last thing we get into is medical Lego kit. I think medical Lego kit for us is probably the ultimate, and this was pushed directly by the COVID-19. During COVID time, the whole medical system, everybody has embargo to ship any medical system out, including even the joint for those oxygen plug, okay? So Japan, Korea, Europe, most of the people has their medical devices, certification, and all these products directly from these places, and they're all embargoed. So we pitched to the government, says we were very stupid. We said we can do this in 8 months. We can build a COVID hospital, all with local trash, okay? So, and we kind of get the WH standard during that time. And so now it's scaling to the 3rd hospital now. And just quickly give you what we mean by a smart machine. We have a lot of these smart machines currently that's around the world right now. This is one of the things that we did for Neom City, and now it's expanding into the 2nd line and 3rd line. Basically, it's taking local waste and turning it into building material. And this is a Neom City in Saudi Arabia. I don't know if you know this very futuristic, crazy projects. And this is the infrastructure, and it's going to the 2nd phase. And just imagine what the trash can be. It can manufacture door handles. It can manufacture picture frame, all within 0 distance, yeah? Where trash happens. And this was in Singapore Trash Kitchen. This was in National Design Center. Now it's in Sentosa. Hopefully you will see an activation in Sentosa permanently there soon. And this is in Taipei, where we link with universities. And of course, everything can be robotic. It's all computer controlling drones. And so so pretty much you can make it anything. Thailand. So this is a smaller size. So basically, this is a baby recycling plant designed to be air transported and fit into elevators. So every machine is just 1 ton, okay? And then they can be folded into a Swiss Army knife, and then they can be pushed into an elevator and an airplane. So we can transport them. So we have 7 of them around the world. One of them is being set up in Boston, linking with MIT and Harvard and with Nanfeng Group at their new life science building. The other one is community size, a village scale, where a community, just imagine HDB housing, and then you can take that trash directly locally, and you can directly turn that into something else. And this is what we have in Taiwan, and we are building this in UAE right now, so the big ones. So we're currently building much bigger ones there. The next thing is data, how we link that with data. Everyone talk about carbon footprint. Sustainability is a dirty word, but actually there is a standard started by the European 40 years ago. It's carbon trade, and that is based on ISO 14064, and this has been standardized for the last 30 years for those who doesn't know. So for those, I know there's a lot of greenwashing consultants out there claiming there's so many different ways of calculate carbon footprint. Sorry, there's only one way, and you can actually download it, you know? And please, welcome to read into that, and how looks like a complicated process, but in reality, it's just a bunch of data, put it into a formula, and that formula is very straightforward. Transportation, energy use, and what is the result of that? You know, what's the result of that? The global warming potentials of those data. And then the next thing is the modularization of all your design, architecture design. Unfortunately, architects still design in 2D, which is horrible, yeah? They still draw AutoCAD, it's still single line. Just think about it, single line. The line just have distant data, right? Point to point, 2D, yeah? But in reality, you want to get to that, you need to have everything in blocks and 3D, yeah? And unfortunately, most architecture software, I know there's beam systems starting, but that's from the engineering side. But on the design side, almost not really, okay? And so that you can turn into all these fancy places. So right now I'm done. I just want to show you all these fancy places that you can build with the same logic. So right away you can do carbon footprint analysis. Salad Stop in Singapore, headquarters of real estate companies, one of the biggest shopping malls currently almost opening in Hong Kong. Okay, you can see all that orange and carbon footprint and the medical system I talk about. The last thing is wherever we go to the local collectors. We want to figure out the local trash ecosystem. I was in Africa. I was in Mozambique. I was just so happy and surprised that in reality, the recycling system is actually complete within the plant. It's combining 4 or 5 different companies in Taiwan together. And from buying the trash, all the way to sorting, all the way to palletizing, all the way to the machinery. And then we are building this for the UN Habitats and with different foundations that's sponsoring these. So they can have these medical grade surgery room, ICU rooms to reduce contamination and increase healthcare. So this is kind of where we are at. We can talk about that more later. Thank you.
Thank you, Arthur, for the presentation. Now, I don't know if anybody realized creativity and sustainability usually comes hand in hand. And after seeing what Arthur has showed us, it got me quite excited thinking about how much more avant-garde buildings and designs that we might be able to see and have in the future. All right, and in the pursuit of creating sustainable urban solutions, another trend, apart from creating zero waste, that's up and rising, would be the use of 3D concrete printing. Now, offering the potential to redefine the way we build and inhabit urban spaces, we'll now explore the house on designing for 3D concrete printing. And to speak to us a little on that, let's welcome computational design specialist at Whittier Nibbles, Sean.
Hello everyone, my name is Sean Wu. Today's topic I want to focus with you is so-called pushing the boundary and design for 3D concrete printing. Our company is so-called Whittier Nibbles, not very easy to pronounce. It's basically we are a design engineering consultancy firm headquartered in the Netherlands. We design for building, bridges, tunneling, infrastructure, cycling, anything that's related to the built environment. We have a team so-called digital construction. And what we are aiming for is to digitize and also to automate our architecture, engineering, and construction industry. And today's topic, we focus on concrete printing. And since 2016, we've been really trying to research how can we use a 3D concrete printing and to realize into practice. So since that, for example, the bottom left image, we do like the very first low-bearing bridges in the Netherlands in 2017. In 2022, the bottom image that we do for the pavilion, the highest one, the concrete printing structure, is about 12 meters high. In 2021, the bottom left image, we do the longest 3D concrete printing bridge spanning 30 meters. And we also do the very first livable concrete printing house in the biggest image one, 2021. And since then, it's still very important to talk about why we do 3D concrete printing. First one is really about the construction productivity. If we look ahead the next 30 years, we see there's a 30% increase the demand for housing, for infrastructure, and for anything related to the built environment. But we also see that there's a minus 30% for the workforce, for the labor. And to mitigate these differences, we see that digitalization, automation, and 3D concrete printing can be one of the methods to mitigate these differences. And another one is also about the design to construction process, just like the author talked about earlier, that a lot of us, we still use like 2D drawing and to produce, even though we have like BIM, we have the 3D, but most of the time we produce like 3D, but we still generate like 2D drawing, and you have a document, you hand over to the contractor, and the contractor will teach the builder how to build it. So it has many, many stakeholders involved, has many, many processes. It's quite, the process is quite long and complicated. And the reason that we do concrete printing, the reason we do digital construction is we can directly to produce, to fabricate our house, our built environment using digital data. So it can be like from like BIM data, can be like from the 3D model, and then we can translate this digital data into bit and byte, and using robot, using 3D printer to print. So in the process, there's no 2D drawing involved anymore. And this is one of the projects we did in the Netherlands. We call it like this is a construction worker, so it's very lonely, that the robot can do majority of the work that's trying to print the structure for you, but you still need a human to supervise the process, to look at the quality, is everything good. And yeah, sustainable urban solution in 3D concrete printing. These are the things that we think they could be the added value for our built environment using concrete printing. First one is we actually use less material. For example, the bridge we're printing in the Netherlands, we can use around 50% less material compared to the traditional bridge. So less material also means less CO2 emission. And when we print concrete, the biggest difference is that we don't need any formwork. The concrete we print, it needs to be flowable from the mixing system to the pumping system and all the way through the hose and through the nozzle and get it printed. So the material needs to be flow enough, but also need to be strong enough to support the layer you deposit on top. But there's no formwork anymore. So traditionally, you have to have a formwork, you put the reinforcement in, then you cast concrete. Once the concrete hardened, you remove your formwork. So in a way, you are building your structure twice. First one is formwork, second one is your concrete structure. When we print concrete, there's no formwork anymore. Fourth one, we want to have less dependency in labor. So in concrete printing, the robot can do most of the job for you. Streamline design the process from design to production, and also we have a higher design freedom in shape and also texture. So printing a curved shape or printing a straight one, it doesn't really make any differences in concrete printing. So you have more freedom in design. The last one is, so you have a highly customizable design for our construction project. And our construction project is not like car industry. Car industry, you can produce the same car and you can sell it in UK, you can sell it in Indonesia, just use the same car. But for our construction industry, we are really after mass customization because every project is different budget, different client, different weather, different history, everything is different. So we really need to use a customization, and this is 3D concrete printing can offer. But from technology perspective, this is the challenge. Everything we print is a fresh concrete. So fresh concrete is like a mud. And this is supposed to be just a straight cylindrical column, but it buckle and then it tumble down. And this is what happens when you print too fast, which means the material doesn't have enough time to harden, to stiffen, to support the weight that it deposits on top. So we cannot print too fast. But if we print too slow, meaning the layer that we printed already dry up, and when we lay the next layer on top, you don't get any bonding. So we lost the structural integrity. But luckily, so we can't print too fast, we can't print too slow, but luckily this window is quite large, which gives us this window is quite large, which gives us a flexibility to design. So this is where the research comes into play. We basically use a geotechnical testing method to test our concrete printing material. And we look at that, okay, you print in layer, but we had the building code for concrete structure, but we don't have the building code for layer-based extrusion process concrete structure. And the biggest difference is if you print in layer and you're trying to test it, actually the structural behavior is different in three different directions. So we have the X direction, Y direction, and Z direction. So we do a lot of research together with the university and to look at the structural behavior and also understand the mechanical properties and to use it for as a structural material. So in 2017, we thought like, okay, now we understand the material, we get it tested, maybe we can try to use a concrete printing for the real project. So first one we did for just a simple urban furniture is a picnic table that we still use it in the Netherlands. And this is the printing process, so layer by layer. And you can actually see this is a gantry printer. And the nozzle is always turning to follow the tangent of the print path. And we thought that, okay, this should be quite easy to print, just print in layer to follow the print path, and around like 60 layers, then it's finished. But soon enough, we find out something very interesting and very challenging, is the corner. Every time when we have this sharp turning, the sharp corner, and also because the nozzle is always turning to follow the tangent of the print path, this is what happened. During this turn, the material deposition is different between the inner radius and also the outer radius. So the inner radius always got compressed a little bit, and the outer radius always like stacked a little bit higher. For one layer, there's no problem. 2 layers, there's no problem. But this difference start to pile up. And there's 1 layer, 2 layers, 3 layers, and eventually it will collapse. So we really need to like take this thing into consideration and not just think like concrete printing can just lay. It's also about like how you adjust your material properties. So we very quickly use computational design software in Rhino and Grasshopper. So when you design the print path, you immediately can see is the curvature that is too sharp that will cause this inner radius and outer radius issue. And so when you make the design, you already can analyze it. Then knowing that your design will be printable, will be okay. And yeah, this is our very first, just a very simple picnic table. Last year I went there, it's still in the very good condition. And next one, we go to infrastructure project. So this is the very first load-bearing bridges we printed in 2017. It's 6 meters in span, 3.5 meters in wide. Not very, very interesting design, but we're trying to understand, would that be possible to use concrete printing for public use, for load-bearing structure? And it actually caused a lot of the discussion with government, and how do you make sure this layer thing is durable? How do you maintain it? And since we are also using less material, there will be shrinkage during winter and summertime, and all these things need to be addressed. So, yeah, everyone have a concern. Everyone want to know like how can we control this risk, control the uncertainty. So, risk is not the issue. The main one is how do you manage your risk. So before we printed a full-scale bridge, we actually printed a scale bridge, a 50% smaller scale bridge, and we get it tested through destructive testing, and we use a 4-point bending test. Just trying to understand, is concrete printing structure behave the same as normal concrete? And in the end, yes, it's still concrete material, it's still concrete structure, it behaves just like a concrete. Then we go to full scale. So this is actually the cross-section of the bridge. We print like a honeycomb structure, like a hollow core structure. And also very big differences is we don't fill it up. We can directly use the printed structure as a structure. So most of people, they only print the skin, they put the reinforcement in, they cast concrete. That is use a concrete printing as a permanent formwork. That is good for step in between. But what we are after is this. Just to place the material where it's needed and don't fill it up. This can save material, and also it has a customization purpose. And then we put the bridge in position. And finally, since this is the very first concrete printing bridge, everyone have a concern. And the first day when we open the bridge, we invite our contractor, our builder, our engineer. The cycling is the thing in the Netherlands. We ask them to cycle through just as a final test that since we do the design engineering, we are liable, then we will do some cycling, and then we get it through just to prove that we are confident in our design. So we know this very first bridge is not very beautiful, safety factor is quite high, it's also not really like introduce the design freedom, but at least that is the first one that trying to use the innovation in the real practice project as a low bearing structure. The next one, we do one step further, which is also the bridge, but the span becomes 30 meters, and also introduce this curvy organic geometry that can blend into the environment. And soon now we realize that for this kind of the concrete printing bridge, it's very important you have a parametric design model that can control, for example, length, width, height, so you don't have to repetitively to design every bridge again. Once you have one good parametric design model, you can very easily to apply that what you have learned before to the next bridge to save your time to focus on what is unique in the next project. So this is actually this is the printing process for in the one part of the bridge. So basically the printing strategy and also the pattern is still relatively similar than the previous bridge. Still like the honeycomb structure. And for example, the left image is the column. We print it upside down. And during printing, we put this lightweight aggregate to support it because we're still printing fresh concrete. If you have a crazy overhang, you always collapse. But by introducing this temporary support, that allow you to have more design freedom, different curvature, incline angle to fit with your design purpose. So this is during the construction process. So every span is 6 meters, so 6 meters, 6 meters, 6 meters, and you can see how nicely the curvature is blended into the printing process. And this is the final bridge. So these two bridges and also the picnic table, it was done in the Netherlands, but we also do all different kind of concrete printing around the world. Of course, in Singapore. In Singapore, we always talk about like how to push the construction productivity, how can we reduce the dependency for labor. And in 2018 to 2022, we actually work on this 3D concrete printing project for HDB. This machine was installed in 2019. It was the largest gantry printer that we had, and it was meant, for example, to print the modular unit, such as a PPVC. And this is very first task is hey, how can we print concrete? Because Singapore, now like in the Netherlands it has like the winter time and summertime. So actually during different seasons, we use a different parameter to print concrete. But Singapore, the weather is actually quite stable, quite constant. It's always hot, always humid, and we actually figure out Singapore is actually relatively easier to print because environment is very stable. It's humid, so that's good for concrete printing to cure. If it cures too fast, it always crack. And this is one of the process when we print the very first PPVC unit. So again, it looks like a construction 3.0. The robot can do it for you, but you still need to have the human to supervise the process. And this is the final outcome for the first the unit. So it has all the reinforcement, including and also joint connection, and put the drywall, window fitting, and also the surface finishing. And this is the last one that I want to show you how do we print this modular unit. And since 2016, we've been developing many such concrete printing projects. And we always tell this is actually the secret to have a successful concrete printing project. 3D concrete printing still remain in the growing phases. The market is still relatively low. And in Singapore, government is really have a very important position. They're trying to push it. They give funding. They give opportunity. They allow you to print it and get it tested. So Singapore have very good environment for such a printing project. And I always mention this so-called golden triangle. For innovation, you always need to have government to provide you this funding to help you to do the first step. This is Singapore always doing very good. And university, they can do very nice fundamental research. So they are good in material research, develop material, they have their testing lab, and also all the equipment. And we, as a consultant and also contractor, we are able to translate whatever is done in the research into practice, and so we can apply in our construction project. And without such a golden triangle, without collaboration, most likely it won't work. So we always trying to push to have a project, and we figure out how can we form this golden triangle. And with that, I want to thank you for your attention.
Thank you, Sean, for the sharing. All right, I think as Sean has mentioned, 3D concrete printing was still at quite an early stage. So now, to give us a more global perspective on 3D concrete printing, we have invited Simon Klimber, the co-founder and head of APAC of Cobalt.
Hi, everybody. Thank you so much for the opportunity to speak here at GAMS. I hope I can give a little bit of inspiration to what's happening around the world with 3D concrete printing also. As Sean rightfully mentioned, there's a lot going on in Singapore, which is fantastic. All the universities are very active with this. So with the knowledge of what I'm showing you today, hopefully we can push it even further and get it out into the real world also. So yeah, my name is Simon. I'm a co-founder and head of Asia Pacific at Cobalt. And I quickly want to show you a project here in the beginning, just to kick everything off, and then we can speak a bit about the technology as such and how it can help in terms of sustainability as well. So let's start with this. So this is a house that actually has been done in Texas by Perry today. It is being finished and fitted right now, so it will probably be PR'd hopefully soon. This is a video showing the build-up process of our machinery on site and printing. So you can see it's a big modular gantry system. Here they're trying to use the form freedom of the technology, the lack of formwork, as we've heard about before, to really create something unique here. So this building is exactly made as a high-end house to be able to really play with the light. So to the next one. Good. So Cobot, who are we? We are a technology provider. We make and R&D the technology that can enable people around the world to 3D concrete print. So we sold more than 75 machines to all over the world. We have 10 machines here in the APAC region. The most of the machines are in the US today. We're a Danish-based company, but with local offices here in Kuala Lumpur, not too far away, and in Miami to service the American market. So we have the approach that we can't do everything. We need strong partners in order to bring this technology to fruition, and therefore we focus on the core technology, the 3D printing technology, how to extrude concrete and fluid materials in the right way, and then we work with partners on materials and so on. That means we're actually open source in terms of material, and we work with various different partners around the world on how to apply the technology best way possible. So our backing, we're very proud to have these companies as our shareholders, GE, Holcim, Cemex, and Perry, all helping us to bring this technology to the position it has to be in the future. I think it's quite significant here to see, and it speaks to the partnership model that we have, that we both have Cemex and Holcim as our shareholders, actually competitors in their fields of cement production. However, because no one partner can do everything around the world, we need a diverse portfolio of partners and who we're working together with. So if you look at our system, it's a modular gantry 3D printing system. It can either be a 5x5 machine, or you can go all the way up to 3,000 square feet in 3 stories height, directly printed on site. We are working with even bigger machines now as well for windmill turbine tower applications with General Electric. So the max width is 12 meters, and you can go very, very long if you want, and approximately up to, it says 8 meters, but one of the projects I'll show you is actually directly printed 10 meters on site if you elevate the machine itself. So if we look at the benefits of 3D concrete printing, we generally see 4 answers. These will be different depending on where you are in the world, and for some will be more interesting than others. I'll focus on the sustainability part today, but I think it's important to mention that automation and the speed of construction are 2 very relevant factors as well. We heard from Sean, lack of skilled labor, the housing need is really growing, so these 2 are of course important things for that as well. So when we speak about sustainability, we have to speak about 2 things. The form freedom that we can use to our advantage, and the second one is the materials. Now we have a new technology, a new way to put out our building materials, which opens up the doors to think new in terms of material as well. So we have been working a lot on making our system receptible to a lot of different types of materials, you could say. So we're open sourcing materials. We have been working a lot on making this real concrete and not just mortars, because most of the prints you will see are mortar-based prints, so meaning high cementitious rate and sand. We want to, or we are printing with real aggregates up to 12 millimeters of size. These can be recycled aggregates, these can be normal aggregates, and a lower cement content because we have additives to do the work for us. So if we look at that in numbers here, we have the opportunity to locally source these materials because we're batching them on site. We don't need to have a dry mix that's made in specific places and taken in. And this really gives both in terms of a CO2 perspective, lower cement, less transportation, a big benefit, but also in price. We typically see somewhere between 5 to 10x in price when you work with mortars instead of working with locally sourced concretes. So how that works is we take 99% of the material locally. So the sand, the gravel, the water, the cement, and it could be other binders as well. It didn't have to be cement. And then we have an additive mix, an additive set, and our technology can then dose that additive to make this printable. Because it is a very special material we need in order to stack it. We need it very pumpable when we first mix it and get it through up to 40 meters of hose in some cases with our biggest machines. But when it comes out, it needs to stand, right? It needs to retain the shape that we intended for it. So with 2 additives in the printhead itself and with additives at the batching plant itself, we can actually achieve both these 2 actual contradictory parameters, right? So, and that works really well. You can see a couple of houses here printed actually back in 2020 when we first started with this concrete technology. And the important factor here to look at is the lowest number, which is the cost per cubic meter of concrete printed in this house. So by those prices, we can now compete with conventional technology in price as well, which is really, really inevitable if we want this technology to succeed in the global construction market. So the second one is the form freedom that we now have gained. We are not bound by the formwork anymore. We can actually use the shape to our intention. So instead of building and constructing how we've always done, let's now use the form freedom of the technology to create something new. So if you look at these 2 cases, I'll come into it in a real case in a minute as well. By utilizing round shapes, we have much more material efficient shapes for gaining the same type of area. So what that means is, for example, this case, which is housing units for the Philippines, 24 of them. The proposed design was the one on the left, which is a standard square design of buildings. And on the right, we did this very natural looking shape, which utilizes round forms. And the beauty here is that not only do we save about 10% on material when printing this contra the other one, we also gain a lot of other benefits from it. We get something that's more aesthetically pleasing to the eye. We get something where the natural shape funnels the wind through, so you get a better inner climate. Yeah, all in all, also a better printing time because we can do this in one continuous print back and forth. So we have no travel time in a design like this. So by thinking creatively with these new possibilities, we can actually optimize on a lot of parameters. A real case here, just printed in Germany by one of our clients, Röser. They've been working with MC Bauchemie. This is a geopolymer print, a prefab print in their hall and taken out to site and assembled. So this binder material is actually with 70% less CO2 than a standard cement. So by unlocking the free mindsets that we have with the new technology, we can then also now look into new materials. And then on the end notes here, I just want to show a couple of projects done, so you can see it's actually happening. It's in real scale today. This is back in 2020, a house printed by Perry in Germany. The beauty here is they utilize the design to optimize on their on the other trades afterwards. So by enabling through design that all the holes for plumbing, electricity, and so on were already there, the conduits were there in the printed design. They saved from 13 days down to 3 days of those other trades afterwards. If we look at a project that also is just done printing and will be very soon PR'd as well, is the server center in Heidelberg. Just done, it's 50 meters long. It's not just smaller scale houses we're seeing anymore, it's actually up to big scale as well. It utilizes this fantastic form-free wall wave segment in the front, but the inner walls are all straight, so they get the best from both worlds. Because in Germany they need, and especially for service center, they need temperatures they can rely on, so the cavity in between the two walls serve as the installation space. Also, to show a bit of size here, we have the biggest villa printed in one go as well. This is why I say we can go up to 10 meters. They printed 9.9 meters directly on site in Saudi Arabia. It's 345 square meters printed in one printer installation. I'll just show you a short video of that as well. This is printed with real locally sourced concrete as well. And if you're wondering why it's always dark on the pictures, it's because it's too hot during the day to print there, because it's in the middle of the desert. Great. Just to show a little bit about the speed as well, I want to show you this from Oman, another client of ours that utilizes the concrete technology. I have to say, one of the beauties about concrete is that suddenly, because you have large aggregates and we have the additives in the printhead, we can print not 1 centimeter layers, we can go up to 5 centimeters of thickness. And then you cut the printing time by an immense amount. So these guys, it's Geotech in Oman. They printed 3 houses in 8 days. And that's 8 days from start to finish. And it's including moving the machine, a big gantry system, 3 times, which is quite significant. Locally sourced materials again, hollow structure walls, very organic design. Got it there. Great. Just on an end note here, it's not just houses that we can make with this technology. I think we have to think out of the box as well. We have some of our clients looking into infrastructure. We have GE looking into windmill turbine towers. Tank applications we really trust is a big thing. We need biodigesters for biogas with all the recycling we're doing of food waste. We need water tanks in different places in the world. Everything that's made today where you could benefit from freedom is basically something that the technology could be used for. Yeah, so this is just a picture of a lot of houses printed. These are just some of them. I want to say thank you for your time, and I hope we will have a good panel discussion after. Thank you.
Thank you, Simon. All right, so as Sean and Simon has both mentioned, with the possibilities that 3D concrete printing brings, there are also some limitations and challenges that comes with it, especially when it's related to intricate and fine details like rounded structures. So for the next topic, we're going to zoom in a little bit onto thin shell concrete structures like the one over Pantheon, Rome. They allow us to build complex curve in our structures, but it can't be easy to build, especially with additive manufacturing. So to enlighten us on how that can be done, please join me in welcoming Principal Architect from Type 0 Architecture, Pan Yi-cheng.
Hi, good afternoon. I am Pan Yi-cheng, Principal Architect of Type 0 Architecture. I must confess that I'm a bit intimidated after this great guys has presented, but also super inspired. I guess today I'll be sharing about my recent dabble into additive concrete printing and probably show you the mistakes that I've done. So a bit about my company. We have been doing design and make for some time. So DFMA is really ingrained in how we practice. So very early on, we wanted to ask this question about whether architects should only be adopting what is already available out there in terms of technological production, or can we actually evolve a new type of building with what's currently already available out there. So the building that you see there is Le Corbusier's Domino. He was really ahead of his time about 100 years ago, wanted to mass produce this concrete skeletal building. But ever since then, we've just been creating more and more concrete buildings as what you have seen. But with the new technology that's available, if we know what kind of building, what type of building that we need to create, whether can we shape the tools or invent new tools in order to produce them, and vice versa, to find something that is most relevant, that can optimize the, for example, 3D printing concrete technology that we have now. So to that end, we have structured the company to look into computation, fabrication, and assembly in a way that through every project, we inform each other in terms of all these different facets of running an architectural practice. And over the last 10 years, I've set up, assembled 3 companies looking at different components of design and fabrication. So I have Produce, which is design research. We look into material research, particularly in timber. And then Superstructure is a digital fabrication company. We have CNC machines and slowly getting into additive manufacturing. And then Type O is my architecture practice. We look into how we can change building typologies through fabrication. So a little bit about the history. Produce started first with a CNC machine, a simple one, a 3-axis on the ground floor, and our studio on the 2nd floor. And then in 2017, I collaborated with a material supplier in Singapore and started Superstructure, and now we have our 5-axis CNC machine. And we just modified a 3D printer to print in clay. And lastly, Type 0 Architects. So in our structure, these 3 companies work together on some projects, and we set up a computational team where we use it as a base to internalize all the findings and all the learnings through every project. And here is like an archive where we can use this knowledge to project further into other buildings and other type of workflows. So our project range from very small furniture and products to buildings to even urban plans, all utilizing a computational workflow. And I think of it as a larger project called project synthesis. So our early works involve like studying properties of plywood. In this case, using 2mm plywood and using a kind of simulation of its material property to create almost like a tensile membrane of 2mm plywood. This building, I would say, is a building within a building. It's still in Marina Square. It's been there for 5 years now. So if you are still around, can visit it. And then recently, we created a thin truss structure, likewise, also using plywood for a canopy within an office space. This is at Capital Spring. And currently, we are shortlisted for World Architecture Festival, one of the categories. And in terms of building products, we have started looking at modular acoustic systems where we can integrate speakers, sound absorption panel, and these are like a new type of brick that we try to manufacture, and then you can see them doing a dry assembly in the workshop. And finally, the picture at the bottom is when it's completed. Currently, we are working on the first mass timber house, a single-family house in Sentosa. So really looking forward to showing that maybe next year. But now, let me talk about additive manufacturing and our early stages of like playing with it. So we tried to do a thin concrete structure, shell structure, and basically looking at how it can create a large span space where activities can be very flexible underneath it. So, but the problem with doing shell structure is that there's a lot of formwork required, a lot of temporary structure, which makes it very expensive to build and very tedious. So how can 3D printing concrete be utilized in this case? Right. So these are some of the typical challenges that we face when doing shell structures. And our first opportunity to look into this is to utilize 3D printing and what it can offer to develop something that's organic, non-uniform, and just wanted to test the limit in terms of concrete 3DP. So with that, we hope to eliminate the formwork, allow for high level of customization, create something that's rather complex in terms of geometry. We would want to utilize its precision and material efficiency. So this project was made possible by Keppel Innovation and Technology Group. And like that golden triangle that was shown earlier, this triangle is created by Keppel, involving Wohab, a very seasoned contractor, ourselves as the designer as well as a tech partner, and Chip Eng Sing, who has a concrete 3DP plant in Singapore. So the project is for a little pavilion in the park in Singapore. And simply, we just use its circulation patterns on site to determine that there maybe should have 3 legs. And intuitively, we thought of creating like a folded shell to increase its strength as a shell structure. Something that we think that intuitively with concrete 3DP is something that we can achieve. And then because it's by the sea, we use these strips to create something that mimics the growth of, say, corals and develop into the design of the shell. So here's a little video of how we incorporated a wave function in nature to figure out the texture as well as the form of the building. The overall shell is floated up to form a vault. And then the wave functions modulates the surface texture, increasing the depth of the shell and giving it more rigidity. I mean, we could have put this in Karamba to test it, but just because of time, we did not. And then we thought that we go through a kind of a design and make process to validate some of our assumptions. So finally, we can have a catalog of a huge number of variations, but in the end, we picked one that is not so undulated, but at the same time enough to allow for kind of rainwater to trickle down these different valleys. So as a shell structure, we think of it as to optimize on compressive strength of concrete and reduce the amount of tension in the structure. Part of the base was made bigger and to create a larger base to improve the stability. At the same time, we turned it into a bench. And for a central bench, we also wanted to test polymer printing as a formwork for casting. So this was topologically optimized to form a bench design in the middle. So the size of the pavilion is about 20 square meters, so very small. And as a team, we think that's something that we can test out together with Chip Eng Sing. So in terms of weathering, we design into the structure these different valleys, and we imagine that this will darken over time with the rain. And over time, instead of having to constantly maintain it, the depth in terms of color variation will increase the contrast of all these rips and hopefully make it more beautiful over time. These are some of the early renderings. I mean, I say thin in terms of its layer, but as a module, we think of it as a brick that is then stacked to form this vault, like a masonry vault. So overall, you can see that it's quite thick, but inside we were thinking of it as a hollow structure. So a bit on the fabrication. So we need to use this thing called like non-planar printing. In order to optimize the entire shape, we had to calculate how much of a deviation in terms of angle every layer is going to go. So we work within a range not more than 15 degrees, and that determines the number of parts that we have here. Also, each part is kept to around or less than 300 kg in terms of concrete weight. So each plane that you see there in red is what we're going to lay on the floor as we start doing the print. So it's always planar at that point. And because it's imagined to be, we plan for it to be a live project. So we build in some rebars as it's going to be assembled to increase the strength. So in order to have the rebar going through, we developed the G-code so that we always have a cavity that runs throughout the structure. So the whole computational process gets linked from how we develop the form to eventually getting the G-code out for the non-planar printing. So this is we 3D printed it in our own small 3D printer, and then just to demonstrate that it stacks together. So this was the first print. I mean, we stopped at this stage of just before a proof of concept and started printing one part to see how non-planar printing can be achieved with Chip Sing's equipment. The mix of the concrete is supplied by NTU. So I mean, Vitamin and Boss laid a good foundation in Singapore, and we adopt some of these materials from NTU. And then when we quickly realized that it's not that easy, where we have varying thickness over the entire layer, and that's where the clashing starts to happen. And so this information that gets feedback into our script again, and then we hope that we carry on forward to refine this. The project currently is on hold because the site in NParks site is no longer available, but we are looking for a new home and then hopefully to continue this research together with Chip Sing and Wohab. So just to conclude, concrete 3DP, I think, for shell structure is an interesting thing because it tries to make it structural and a standalone building, just by using the property of the material itself. So in terms of technology maturity, I think what Cobot and my fellow presenters have presented, it's already quite advanced. In terms of material innovation, there still needs to be, we still need to try out different consistency and mix of concrete to optimize and use its property to improve the strength. But I think what I'm interested to really continue to look at is the formal topological optimization of the design in order to best make use of this property from concrete 3DP. And of course, then there is regulatory approvals which will make this more easy to come into the market and make it possible. With that, I end my speech. Thank you very much.
Thank you, Yicheng. If there's one thing I learned from this session is that printing for construction is difficult business. Now, as far as urban solutions are concerned, the properties of raw material, how certain designs might be difficult to print, and most importantly with construction and architecture, there's always a concern for safety, and weathering is also a challenge. So with all these considerations, how then do we integrate urban solutions and sustainability into our very own industry? So now we will invite the 4 speakers up again for a discussion, Arthur, Sean, Simon, and Yi Cheng. And moderating the discussion, we will have Joris. So ladies and gentlemen, please give them a round of applause.
Right. So I hope you all enjoy that. I enjoyed that. So I thought, oh, these are a little more comfortable.
Very comfortable.
Okay. So I hope you guys all enjoyed that. Found that very, very helpful. I did too. I thought it was a good look at a much hyped part of our industry and part of the construction thing. I'd like to see the realism, because there's a lot of 3D printing of buildings in 24 hours, and they never invite me. They always tell me afterwards. So. And I've always told them I'd fly anywhere in the world. If you want to print a building in 24 hours, I'll come. I'll pay for it and everything, and they never invite me. Anyway, so I like the realism, guys. So, so we're talking about sustainability today, and that's one of these subjects that everyone's always in agreement on. It's all wonderful. You know, first off, is it my job as a business to do this? No. What do you guys believe? What do you believe?
No, I first of all, just hearing you from Holland, I know you're very cynical.
Yeah.
But I think the cynicism, I think especially for engineers, believing in being cynical is a good thing.
Yeah.
Because that's how you solve problems. And so for example, I love every single one of the presentation. But for example, for me, I have to face, for example, if I take 3D printing, I have to go face the developers, and then on top, I have to face a committee of engineers who just throwing at you with all kinds of structural stuff, yeah? Okay, and then you prove that, you prove that, you prove that, prove that. So like which developer is going to, the first thing is like, do not make sure this thing do not go through the structural committee. That's the first thing. So how do we get that? That's the cynicism, right? How do we push that into that? And for example, on the government's perspective, like the triangle, right? The government perspective. On the government perspective, to them, their most important mandate is not sustainability, really. Actually, the most important mandate is safety, human safety, right? So that's the most important criteria for their. So you cannot blame them for being review after review after review. For developer, they're like, as fast as possible, let me make money, right? So then you got this dilemma that's facing many of the innovation that we face. And of course, I really have so much respect for, to get 3D printing into the construction mainstream.
But maybe we're like so that's an interesting thing you bring that up. I think that's a really interesting point. And maybe could we be a Trojan horse for doing these more sustainable practices? Because that seems to be the idea, that we can, because on the one hand, a lot of these counties and governments, they do 3D print a bridge. Now they don't do that, well, they want it to be safe, but at the same time, they're doing it because they want to be innovative. Now, all of a sudden, they want to do something they normally don't want to do. They want to show that Nijmegen or some city or Auckland, New Zealand is an innovative, cool city. So all of a sudden, they're going to push everyone to do the right thing. So do you guys believe in that we could be a Trojan horse for sustainability?
Totally. This is a ticket for opportunity, right? I think I briefly mentioned it as well. This is new technology. It's an option or opportunity to think in a new way, right? It's not because you can't cast geopolymer or use recycled aggregates in formworks. You can, but it's not the conventional practice today. But what you see in the 3D printing space is really every other person working with 3D printing are looking into new materials, right? All the universities are looking into how to utilize recycled glass, as here in Singapore, or how to use other binders like geopolymer, or how to use recycled. I mean, our first house was 23% recycled roof tiles as aggregates. New technology creates new opportunity for thinking new. So I believe that's an opportunity we have.
Yeah, and Sean, you guys do a lot of buildings and stuff, and you're in the middle, kind of, right? You're in between the government and the developer and everybody on this. Is it difficult for you guys to move this along in this process, or?
We've been doing concrete printing around already 6 or 7 years. And personally, I feel the most difficult one is most architect and designer, when it comes to 3D concrete printing, they always want to do something crazy.
Yeah.
They want to print a crazy
Kill the
overhand,
architects.
organic stuff. But what's missing is we underestimate the complexity of concrete printing. First, we are laying concrete layer by layer, which means we don't have the building code. But in the Netherlands, we do this. In the Netherlands, there's also no building code for concrete printing. There's no building code for concrete printing globally. But we managed to get permit from government in the Netherlands, so-called design by testing.
Yes.
There are 3 steps. First one is we test the material. We print concrete, and most of the time we still print like a mortar. Now we have larger aggregate, but at least when you print concrete, we need to prove that the material need to be as strong as normal concrete. That's the first one, material. Second one is you print a scale model, you get it tested, through destructive testing, bending tests, and all these things, just to test the mechanical performance. Does it and you check, like, for example, deflection, deformation, does it really match with your structural calculation? If something's wrong, then you have to go back to check your material, to check your design again. But if that is within the range, then you go to the next one, you print the full scale bridge, and then you do on-site testing. You put some like water tank to simulate the design load. Again, you measure the deflection, deformation, just to understand everything is in control. And by doing this step from the material, scale model, full scale testing, then we are able to inform our government that these things are safe. These are the testing protocol, and these are how we print this bridge in a scientific approach.
Yeah.
And we think that this is actually a very practical way. And don't do everything in one project. For example, the very first bridge we printed in 2017, it was not the best bridge. It was actually not very interesting. Just, we call it, we have 3D concrete printing, but it's more like 2.5D, you know? We print that curve, but it's just extruded all the way up. So there's no 3D yet. But at least that was the very first bridge that we print using concrete printing as a load bearing. So we feel like when we first starting this project, we had exactly the same discussion that should we make this, introduce like a lot of the design freedom and all these things. But we realized if we put too many parameters, too many variables in one project, if it fails, then we don't know which one it failed. So we decided to do it step by step, doing something small, doing something that we can control and know what we are doing something for fundamental, and then once we succeed, we get what we learned from the first project, and then 6 meters, 13 meters, this is more practical way. Everyone knows what they are doing.
Okay, I think that's a really good point. I think that's, again, that realism, which I really like to see. I think it's a really good point to make, and I like that you showed people how these steps can be done even though there's no regulatory framework in place. But you did mention of the architects, and it came up a couple of times, and there's this thing in architecture, I think it's, was Semper or something came up with this concept of stofwegsel, where we used to have rugs, right, on the walls. And then later on, we had brick buildings, and then we ended up making wallpaper to remember these rugs. So we're always thinking in the last technology that we used. So how do you guys think that kind of thing, you mentioned that the architects go crazy. That's, of course, as the engineering consultants, you're always going to be driven crazy by them. But as an architect, maybe, how can an architect take charge of this project and still do something, very, very kind of like honest and a good building, if you will?
Yeah, I think from my point of view is I wanted to explore the limitations and therefore discover the parameters out there.
Yeah.
So an architect, without knowing too much about day in, day out, looking at all the limitations and parameters of concrete 3DP, I approach it from more intuitive manner. But the key thing is that there is an intuitive but also iterative loop built into the system that I'm used to doing from a CNC point of view, which I think when you do a first experiment, and how do you diagnose what you have actually created and then use them as useful parameters to create a second loop. So with the new workflow, the thing is that an architect cannot design purely from, without connection with the manufacturer anymore. So with DFMA, you need to be as close to the manufacturer as possible. And I realized after having my own little factory that there is this huge gap in the industry where architects are only creating visions without an actual plan in terms of developing and realizing that vision one-to-one. There's always going to be compromise along the way, either by material problems or some engineers telling you that you don't have enough safety factors and stuff like that.
Yeah, and I think this is a good point. I think this is a really, really good point. I think because before you had these draw architects, like Foster's buildings would exist like as in like kind of a paper, essentially. Or somebody would say, this is a library, I want it to be titanium or some kind of metal, and it's going to be huge, and it's going to be this huge defining structure in this building. I have no idea how to build it. And then they would just pass it along like a hot potato. and so do you think that architects should study technologies, not only 3D printing, but other ones? Do you need to go much, much deeper now? Or do you think there needs to be a new kind of, a person like in between
Exactly,
like the Witteveen and Bos and yourself, a new kind of role?
Yeah, I think the conversation about what an architect is, it needs to be rethought like after so many years. I mean, it used to be a master builder. It's called architect.
Yeah.
It used to be master builder, meaning that the person knows what material is working with, the economy of the material, and then how to realize it from a technical standpoint, right? And that over the, I don't know, decades of architectural education has been lost, has been outsourced to different expertise. And with this new digital age, it has to come back together. And I don't know, I think that's why I started a little factory with CNC machining. It's to get, I just find that something is lost and I couldn't fully be in control of what I'm designing. And I think we need to develop that hybrid. Either I go work for him or somehow they become a harbor for different architecture groups. That would be awesome.
I think that's a good point as well. I think what to me is interesting is that I know a lot of designers, and I did some teaching in design schools and stuff, and some presentations and stuff, and they kind of feel very guilty about making things. And I did a presentation for like a jewelry school kind of, and they also, everything was found and everything was recycled because they feel guilty. But we don't have the product, the developer, his whole métier, his whole thing is to build more buildings. So they don't have that same level of guilt.
Yes.
But should we feel guilty about building new buildings? Should we just not do it? Or should we only do it if we don't have any other option? Or?
I actually don't think sorry, but I'm going back to the old point.
No, go for it.
But because I also went through a very traditional set of architecture engineering, engineering and architects, and we actually renamed our architecture department to call them system integrator.
Wow.
Yeah. And you have to take the ego out of the architects. And by the way, architects is not a master builder, just so you know. They were like master bullshitter. Yeah? So you have to, first of all, start with where the history of architecture is. The history of architecture, there's no architects. There's no architecture department even. Cornell started architecture in 1880s? It's a fake. It's a fake program based on Beaux-Arts. I don't want to debate on whether there's really a master builder, but a master builder normally is just somebody who's organizing a project. It's almost like an executive producer of a film. Do you see what I mean? It's like you have a masons, you have this, but he also have to know about art, a little bit about this, but it was never truly a profession, okay? Until in the US, they started this profession, and then they started AIA, because a lot of building collapsed, yeah? And then Cornell as the first architecture school, MIT is the second one, and they started off as a trade school, draftsman, training draftsman. So you cannot ask a draftsman, if you think about it, to control technology. You know, so I'm not saying.
But you can see the architect as an artist, maybe. But I think it's an interesting point generally to talk about architecture and the role of the architect in the modern society. But like, let's talk about all of you as technologists in the broadest sense.
Yes, I think that's the better conversation because I think what you're doing is not architecture. I think what you're doing is architecture, but doesn't matter. I don't think architecture is the form of that thing. But I think at the end, why we want to do architecture this way, I think this is also very important. But like you said, the impetus to change is very, very low in the real industry, very, very low. And they do it for kind of publicity, yes, but we see possibility. We know the future is like this, lower labor workforce, everything needs to be digitized, and this new possibility. But how do you convince the guy who's paying for it? I think this is the
Money.
Yeah.
Okay, so it has to be economical.
So you're saying there has to be a business case, essentially.
I mean, we can feel that, right? We are speaking to builders and construction companies all over the world, and this is, I mean, all the ones that have bought the technology at this point, they are first movers, right? They are investigating how to
make
be
it
the
cheaper.
first one,
Yes.
to make it cheaper, mostly, right? And we can also see that this is the main barrier for people investing in the technology. It's we need to see proof that we can turn this to ROI, right? And it makes sense. This is how they work. It's low margin business anyways. Everything has to be streamlined. If we cannot see an economical benefit, we won't move until somebody else showed us. So I think that's from our side, one of the big things that has to happen in the next couple of years for this technology really to take off is seeing scale projects, seeing multiple houses, or could be high-rise, it could be mass housing projects done with the technology, where we have actual numbers that our contractors, our clients can look at and say, okay, now we get it, And then we get the form freedom afterwards, right? And we can.
So Sean, I'm interested for you is also about this perspective, like, it seems very logical to build a project. I mean, multi-story is another thing entirely. We can get into that later if we want to, but let's say talk about a project of like, there's guys in the States wanting to do this. They're talking about whole neighborhoods, as they do in America, just like, put a whole neighborhood in there. Do you think that's the future of this? And do you think that's what's really going to be the major proof point? If somebody can make one of these major developments? Or what do you think needs to happen for this to become, more of a business case, more of a business, and more prevalent, let's say?
Yeah. Most people that, for example, developer, property developer, government, when they look at the innovation, and from our experience, for example, we print like bridges, housing, very first thing is not going to be cheap, at least the first one. First one is always 2 times, 3 times more expensive than the normal way we build. Which part is more expensive? Because the time. We need to make sure everyone understands that what we are doing, align the expectation, and then make things practical. So we spend a lot of time on the meeting, on discussion. It's more like to educate people what we are doing. And we learn that once, for example, a contractor and government, they understand our process, and if they apply again, it will be cost competitive. Maybe you won't be cheap, but at least you will be competitive. And for example, the first bridge, and also about, since we have this urban sustainability, right? We also know that cost is not just, it's just one perspective. And also about, for example, the bridge we print, we don't put any rebar anymore. And we use less cement. So even the cost is competitive, it's almost the same, the second one and third one we print, but the environmental impact is way lower compared to the normal bridge we use. We use less material and we basically don't use any rebar in our concrete.
Yeah. And you guys, I think the discussion always drifts to housing, right? I think it's the most relevant to consumers, so the media writes about it the most. Right, but if we're looking at business cases, I love, there's a guy called Boss, he's doing Boss products in Australia, and he's making planters, right? And I love this. Because a planter, you can just make this thing, and just kick it out the door. And usually they do this with precast, right? So you have to make a mold, and you get a certain amount of shots on it. You have to make them dry and stuff. And actually, you could make mass customized planters. And I love this because it just seems like it could be really automated. So do we need to look much more broadly? And what are the structures you guys like apart from houses? Because I think we talk enough about houses already. I mean, are there some kind of like types of things? I love planters. I think it's an amazing application. But there's a lot of bus stations and stuff like that. Are there other kind of buildings or parts of buildings that you guys like very much? Yeah.
Yeah, I'd love to comment on that because I think it's exactly there we have to look as well. We are speaking to a lot of different clients doing other things than housing. So we have GE on windmill turbine towers. If you can get the same turbine 20 meters taller, you'll get 20% more out of it, which is quite significant. Problem is they have very, very thick towers. They have to be transported by road because they are manufactured in a manufacturing plant. You can't go taller because it's a conical shape. So by printing on site, you unlock extra height. You unlock extra potential of these windmills. If we talk about subsea structures, for example, everywhere where we use formwork to create concrete structures today, the formwork and the boundaries are there, and you put in concrete because it's easy. You don't put cores, you don't put hollow spaces because it's cumbersome. It's expensive in time and materials for the formwork. But just as your bridge had a lot of holes inside because it comes for free with 3D printing, there's so many opportunities in saving materials. And the beauty here is when you look at the cost allocation of walls in a house, it's only 20% of the building cost. You have the roof, you have the kitchen, the bathroom, the floors, all that cost equates to the rest of the 80%. But if you look at these concrete structures like bridges, like water tanks, like subsea structures, like whatever other products in concrete you think about, it's the full cost you're addressing. Mm-hmm. You're addressing the full cost of that element. And hence, just the small saving will come back much quicker, right? Mm-hmm. Because you're addressing the whole cost of that object. So yes, I believe it's a really big and important thing to think about.
Yeah. I want to add on that. So we do concrete printing, and we know concrete is actually quite polluted. Cement production is around 8% of the global carbon footprint. But what we are after is, we are not trying to eliminate all the concrete usage in our construction industry. What we are after is trying to use concrete more smartly, more efficiently. Concrete is still a very, very good structural material, building material. It's very strong, very durable, very fire resistant, and low maintenance, and also it's quite cheap. But when we use the concrete, it's very good in compression strength. But it's also about how we design it. For example, nowadays we have for example, you look at a concrete column. We have a foam wall, put reinforcement in, we dump concrete in. Do we really need all this material there? Do we really need to be a square, a cylindrical shape of column? We design as a cylindrical, as a square column is because it's easy to build by human. But nowadays we have robot, we have 3D printer. We can really customize our design in our building environment, in our structure. So I always ask myself that if I have a chance to design a new column, a new building, does it really have to be square? We make it square because it's easy to build for human. But if you look at the structural performance, we actually don't really need to have a concrete everywhere in the structure because we need it for compression, we need it for tensile. For example, Pantheon, the author share, it doesn't have any reinforcement. No reinforcement. It's been there for 2,000 years. Yeah. And that's because at that time, there's no reinforcement, there's no metal. So we have to design in the way that structure is compression only, then we don't need to have any rebar.
Yeah, and they had the granulate was different, right? The granulate composition.
Granulate is also different. So for example, when we print concrete, it doesn't have to be has a cement inside. Cement is basically the binder. But what we are also working on is a geopolymer concrete. It's concrete without cement. And we can use, for example, slag, we can use fly ash, just to reduce the cement as a binder. Eventually, it still look like concrete, still behave like concrete, but there's no cement anymore. I still call it concrete, but there's no cement.
Everybody uses all the terms interchangeably. So, and how about you, we've heard a bunch of different materials being mentioned. We've been kind of cement heavy because that's what was talking about. Are there other materials that you're very excited about, either in additive manufacturing or generally? I mean, you're doing things in wood, very old school material. Do you see that making a comeback? Because it is very trendy now.
Yeah, I mean, if we are looking at embodied carbon, actually it's quite a no-brainer to go back to using timber.
Yeah.
And even fast-growing species like bamboo. There are a lot of experiments in there now, and creating bamboo lumber, which I think is much more effective as a building material, and it locks in the carbon, right? So I think we cannot really talk about meeting all those 2050 targets if we don't address the fundamental way we build. And just now the chart that Arthur was showing, right? I think I saw another chart that says that currently embodied carbon is about 10%, or a quarter of the build industry carbon emission.
It's more than that, actually.
Yeah, but it's going to outpace the operational carbon. That means
it's already outpaced. If you
already.
include cement production, if you include steel production, it's already outpaced.
Wow.
Operation.
Yeah. So, yeah, I think that's why I'm actually focusing a lot on timber construction and trying to bring it into residential projects. Because I think if we want to have an overall impact, we need to look at housing actually. Because that's, I just checked like last year or year before, housing projects is more than 50% of the building stock in Singapore. But if we only rely on one school, one trophy project, it's not going to do much to it. And I think also if you do it for housing, the common people who is actually staying there will start to acquire certain knowledge about sustainability, and this way of spreading through the grassroots, would be a much more sustainable way to extend everyone's knowledge in the built environment and sustainability in the built environment.
And then there's always this belief that again, for you a little bit, there's always this belief that somehow the 3D printing will make people more involved with the houses and their homes, that there's more customization, that maybe people can add to their houses, maybe that you can say, oh, I want this table to be this. Do you believe in that kind of thing, that to make now you're kind of more a passive consumer of your house, right? Come in, you get this model, you maybe change the kitchen, but you have to be very wealthy to build a house, or some countries you can do it, but most countries you have to be very wealthy to actually say, I want this design. So do you think people can get more involved in a kind of a design-oriented way as well?
Because they can see the digital twin already, which, a lot of people couldn't imagine what their house is going to be like until they finally move in. But these days, we can almost have the digital twin of the house customized to your needs within reasons, and then you can actually experience it through VR goggles, stuff like that. So I think it's the technology is already there. We just need to start thinking about our built environment like an automobile industry, for example. That everything is actually built for purpose. Nothing is that you can take out, and nothing is inefficient in the whole way we construct our houses. Yeah.
Okay, I think that's a really good point. There's another good point, is that we were focusing on these walls right now, and the formwork is wonderful, but you might notice that we have a little bit of a problem with roofs. A lot of these things, either people forget to close them off, or then some guy comes and just does it the old school way. So do you guys see an issue? Well, you don't have to talk about roofs. Do you see more of ceilings and roofs or other 3D printing elements inside the building that you guys want to talk about, that you're really interested in? Like roofs, for example, I think is a problem, right? It's difficult with the overhang and everything.
Roof is a funny thing, right? We printed the first house in Europe in 2017 in Copenhagen, and we made it very, very form-free because we wanted to show the world that it comes for free, right? It comes for free when we printed the wall, but definitely not when we built the roof. The roof builder came in and he looked at it and he was like, guys, what have you done? What is this, right? Because everything had to be fit and finished. It looked like 3 leaves that were put together because it was sustainable, 23% roof tiles recycled, blah, 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 all that. And then the roof builder, he just went crazy, right? But since then, we also learned that we had to find a solution for that. So we can actually print roof slabs today as well. By just utilizing the form freedom of the printer before you go print the house itself, you can print the outline of roof slabs that are not square, You can put in whatever reinforcement method, if it's post-tensioning or if it's rebar. You cast out what's needed and then you pull it up. And we've done that successfully on multiple buildings that are of strange shapes.
And
Go ahead.
oh,
Roof is actually a very interesting topic because your ceiling is actually other people's floor.
yeah.
And slab, for example, account for 80% of the weight in the building. And we use a lot of material in the slab, actually. And normally it's quite thick. And also, and this probably because we use a foam work. We just have the foam work, put the reinforcement in, we dump all the material in, and done. But if you look at the structural analysis, you look at this compression line and tensile line, do we really need to have a solid slab? No, we don't need it. If you follow the structural principle line, you actually can use minimum amount of material to make your building lighter, beautiful, integrate with your NEP, your mechanical piping, this kind of thing, into your flow system. But the only way to make it possible is to use your digital data to fabricate the slab. Because if you tell your contractor, you builder, hey, this thing needs to be 5 centimeters less, here 10 centimeters more, they're not going to do it. It's too complicated for human. But for robot, for 3D printer, they don't really care about the complexity. There's no added cost on complexity, which give you a mass customization opportunity to designing the slab to make your slab lighter.
Bon, you did a bunch of stores and stuff like that as an architect and stuff like this, and how about those interiors for like the commercial building space and stores? I mean, I know we're getting companies that do it as a one-off, like, look at us, right? Do you think that it's going to become like something common that everyone's going to do it? Can we do that, or from a design perspective, or would that be very difficult?
To do
Just recycled everything in the store, like the furniture, the elements, and the facade elements and stuff inside? I mean, you're doing it for certain things. I'm going to ask the same question to you as well, but you're doing it for certain things. But do you believe that it's going to be something that's going to be more common? Can we promote that through 3D printing as well? Because that's a lot of material as well.
recycling is not in the psyche of most
Yeah.
most practitioners, actually. Like you have to reinstate a shop after the previous tenant moved out. And everything goes to waste. I mean, there are certain ways of sorting in Singapore, but like we have heard from others' presentation, it's they go to other countries too.
Yeah.
Or they end up being burned.
Yeah.
Right? So I don't really know how to solve this, but particularly with timber, we imagine that the end of life of a glue lamp beam can turn into a bench, but these are all, we haven't got to the point to turn the circle yet, you know? It's just a statement.
No, may I add, just from your point, I really, first of all, kids read this book about, not like kids book, you know, with 3 little pigs.
Yeah.
Right? The first guy who built with a straw, the second guy built with wood, the third guy built with brick. Okay, 3D printing to me is like a brick. Like, you know, it's like, it's in a new generation of bricks, yeah? Okay, then you got the wood, yeah? And then you got the straw. What are the straws? Straws are actually the trash of agricultural manufacturing, right? So you gotta think about it. In our psyche, the straw is horrible. It's like the worst, like the wolf comes in, blow the house out, right? Then you got the wood. But we do have affinity for wood. Everyone relate wood to leisure, light housing, right? It had that warmth, the growth, the organicness. Okay, but it burns like crazy. It's the B3 classification, right? So how do you get that into a, and then you got the brick, right? So I think one of the advantage for 3D printing is that the fact that it's cement-based or is a type of mineral-based type of, well, you got to think of the 2 type of houses, the one just with the pig, are all organic-based, yeah? Then all of a sudden you get to mineral-based. Mineral-based doesn't burn. It's naturally a material, right? So, and then it's naturally heavy, you know. So I see the advantage of the printed house. But in reality, everybody should be living in straw house and dirt house and trash house, because that's the only way to save carbon footprint. So now it comes down to consumer sentiments. So are you going to be able to put people into a hemp house right? Or a hemp house? Are you going to put people into a wood house? That's unfortunately, every time that you put people in a wood house, oh, it burns. Oh, So they got the concern. At the end, if I can have the money, I want to have a brick house. I want to have a concrete house. I want to have a glass house, right?
Until you change that, right?
So how do you change that? I think that would change the demand. Yeah, I think. And I think the 3D printing, one advantage is it already is a mineral-based house. Yeah. So, I mean, by the way, material is divided into organic and mineral, right? And the 碱基发水泥, yeah. No, but for example, how do you make cement more organic? Then you have the base activation catalyst for that would reduce carbon footprint by a lot instead of going to a furnace, right? You get using a chemical way, but it still is chemical footprint. But I think the paradigm has to shift to how do you actually make sure that the lowest barrier entry allows the massive amount of people to accept a certain product. And this is, I think, my journey is one of the hardest thing is to recognize I cannot do too many cool things. I have to kick out the cool things. I was like,
Hermé has a thing. They have a little thing that has, I think it's about 12 little wooden blocks, right? And then you have a little ball. You can roll it, and then it knocks over the wooden block.
Yeah.
And it costs $2,000, right? Right? They make scarves for 1,000 euros. You can go to an Hermé store and buy a 1,000 euro scarf. We could buy $100 bottles of tequila. But tequila costs like $1 a liter to make. You buy. Some people go out tonight and have a gin tonic from a 100 euro bottle of gin. Isn't it just marketing? Don't we just have to, maybe we're being too honest.
Yes.
Maybe we should just fool them like the people selling them all the horrible things.
This is where I thought architects' new role should be.
Yeah, I think the thing about, I guess a philosophical question, like how this whole notion of value, right? I mean, we build cheaply in concrete now, because a lot of the construction is outsourced to foreign workers. But I guess during COVID, we realized the true value of not having these workers and their living conditions and all that surfaced. And that's why productivity actually makes a lot of sense, like to use 3DP to improve productivity, reduce the amount of labor. And that should, in my mind, make the production of houses or our built environment cheaper. But that's only because we didn't think about the real value of labor. So I think now it's how do we get consumers to adopt a straw house, for example, is that they need to know what the real value is of not doing something sustainable. I don't think, maybe taxing is not the best way, but one way. But I don't know. I think like what you mentioned from children, like Three Little Pigs. That you start telling them, getting them involved in the sustainability, environmental sustainability, and doing things to help with the environment. Should hopefully get the next generation to be a bit more aware of this.
Okay.
Yeah.
I think on the industrial side, we noticed that 3D printing is really valuable to a lot of companies as kind of an industrial duct tape, industrial strength duct tape. They don't know why to buy. If you think of a large, let's say, drinks manufacturer or a large food company, FMCG company, 3D printing for them usually has very little value initially. But if you convince them to put some machines in there, they will at one point have some kind of disaster, and you can avert it with 3D printing and make an improvisational part. Do you guys see something like that in the urban space? That 3D printing can be used to improvise, to build things quickly, to quickly adjust to new structures, new realities? Do you see that it could lead people in that sense? Is anybody with me on this? Or?
Definitely. I think, and you touched upon it, Sean, on the foam freedom, and we are doing boxy shapes because that's what we can do today with Foamworks, right? I think our minds are not fully reset, right? We need to start thinking out of the box. What can we do? I mean, road dividers are squares because that's what's easy, and we put them up like this to form something we need. The same with a lot of other things in our environment. And now we have the opportunity to actually do it as we need it, and only do it when we need it, because a road divider can be done in 30 to 50 minutes, for example. So I think it's a whole other mindset we just need to get ourselves into. So get our feet wet.
Thank you very much, everyone. I think I like that. I'm already going to think of a new business that's going to be making curved picture frames. Because none of the picture frames are going to work if we're going to make all the walls curved. So that's a real, that's going to be a real niche, making the world's first curved picture frame business. Anyway, thank you guys. I learned a lot. I thought this was a really great discussion. And I'd like to thank my panelists very much for being here. I'd like to thank you guys very much for being here. This is wonderful. Thank you very much.
Thank you, our panelists and our moderator. Can we invite the gentleman to take a picture, please? Yes. Thank you very much. Ladies and gentlemen, a round of applause. I think to very quickly sum up this discussion one last time, I'd like to bring up what Simon said during his presentation, which is we cannot do this alone. Along with investors, which I agree is very important, and the three prongs of people that Sean mentioned, the government, the schools, and the industry experts, if you will allow me, I'd like to add another group of people to this very important people, which is the people who believe. Yeah, as idealistic as it sounds, I think adopting sustainable solutions in our industry and practices takes people who believe. People who believe in the potential of the technology, people who believe that now more than ever that sustainability cannot wait and calls for it to be used. And only with it will technologies like AM be supported and accepted as a solution to tackle the challenges of urbanization. So as awareness and adoption and acceptance of the technology grows, I look forward to a future where sustainability will no longer be a buzzword, but a way of life. And with that, we will break for tea for the next 25 minutes, and we have prepared refreshments for the third time today for everyone to enjoy outside at the foyer. Please join us for the last session of the summit at 4:40, where we'll touch on the topic of renewables and environment. Enjoy, and I'll see you soon.